Hello everyone. Today we are back with another question on LeetCode, that is remove duplicates from sorted array. Second. So yesterday we have solved one problem that was remove duplicates from sorted array. And this is the extension of the problem that we have solved yesterday. So let's see what this problem is saying and how it differs from the problem that we have solved yesterday. So this problem is saying that we have given an integer array nums that is sorted in increasing order. We have to remove duplicates in place such that each unique element appears at most twice. Means we have to remove elements from the sorted array which are duplicates. And yesterday the problem we have solved said that we can keep only one element. We can't keep duplicate elements, but here it is saying that we can keep duplicate element, but each duplicate element can occur at most twice. It can't occur more than two times. So this is how this problem is different from the problem we have solved yesterday. And we have to perform this operation in place. Means it is saying that we do not have to take some extra space to solve this question, and the relative order of the elements should be kept the same. Means as these elements are arranged before solving the problem, after the final result, this relative order must be preserved. Since it is impossible to change the length of the array in some languages, you must instead have the result to be placed in the first part of the array nums. More formally, if there are k element after removing the duplicates, then the first k element of nums should hold the final result. It does not matter what you leave beyond the first k element. Okay. So basically, after the final solution, the final result would be stored at first k element in this nums array. Okay. And this case basically representing the size of the array after the final solution. So basically, at last we have to return this k after placing the final result in the first k slot of nums. After that, it is saying that you do not have to allocate some extra space as it is already saying in place. So we do not have to take some extra space, and we have to perform this operation in O of 1 extra memory. Okay. Uh, and finally, this solution, this method you are implementing will be tested against this code. And it is saying that this is the input array, this is the expected nums, that means this is the final array. And this case basically calling your implementation that you are going to implement here. And after that, these two assertions will check the result. If these two assertions are true, that after that, finally our solution will get accepted. Otherwise, it will simply get rejected. So let's try to solve these both questions. For that, I'm going to take this second example. Okay, let's go. So here we have given a question, and this is the array we are going to perform the operation with. And this is basically the array we are taking for visualization. So as it is saying that we do not have to take some extra space, but as I have decided to explain the brute force code, so I'm going to explain the brute force code for this solution, for this question. So the brute force approach is that we can take HashMap to solve this. So how HashMap will work? Basically, what we will store in HashMap, we will store this every element as key, and the number of times this element occurs in this nums array will be stored as a value. So this we will take this 0, and as this is occurring for 2 times, we will store 2 in the value. After this 1 is occurring for 4 times. This 2 is occurring for 1 time, and this 3 is occurring for 2 times. And it is recommended to take linked HashMap instead of HashMap because the question is saying that we have to maintain the relative order. And inside the HashMap, the insertion order must not be preserved. And we have to preserve this relative order. To preserve this, we have to take linked HashMap. Linked hashmap makes sure that the order in which you are inserting the element into the hashmap, this element will be removed in the same order. So it is recommended to use this instead of hashmap. So after this, what we will do, we will simply traverse this num array and we will store each and every element into this hashmap where key represent every element and value represent the frequency of these elements. And after that, what we will do, we will simply traverse into this hash map And by traversing this hash map, what we will do, we will take a counter here at 0 index. After that, we will start storing these elements. What we will do, first we will come here and see that this element is 0 and it is stored for 2 times. So what we will do, we will store this 0 here. After that, increase the counter. Again, we will store 0 here and increase the counter. So counter will be here. After that, we will see for 1, as this 1 is stored for 4 times, but we do not have to take this 1 for 4 times because we can take each and every element at most twice. So we will store this 2 for 2 times and increase the counter. Finally, our counter will be here. Now we do not have to take this 1 because it is already taken for 2 times. Now we will come to add 2. This 2 is and 2 has the frequency of 1, so we will store 2 in place of it. After that, we will increase the counter, come to 3, and as this 3 has frequency 2, so we will simply put 3 here, increase the counter, and this 3 will come here also. And so these are the first k elements that are actually representing the final result, and whatever we are leaving beyond it is not going to affect the actual solution. But as we are using hash map here, so it is taking extra space of O of n to store all the keys, and O of n to store all the values, which is equal to O of 2n, which is approximately equal to O of n. That is the linear time complexity. So this solution is actually taking linear time complexity, but our question is saying that we have to perform this operation in constant space complexity. So we have to perform this operation in O of 1. So let's try to make an algorithm that will solve this problem without taking any extra space. So what we will do here, as in yesterday's question, we have taken 3 pointers to solve the problem. Here we are also going to do the same. We will take 3 pointers, I, J, and K. After that, what we will do, this array we are taking just for visualization. This is not the not any extra space that we are taking. We are just trying to show that how these elements are finally stored. So we are taking these 3 pointers. Now I want to discuss that what these 3 pointers are actually representing. So this I pointer represents the place that is already filled. So this I pointer will represent the place that is already filled, while this K pointer will represent the place that is needed to be filled. That means it is not filled now, but in future when we will get the particular element, mm, then after we will fill this K position. So this K will simply represent the place that is needed to be filled. And what this J pointer will do, J pointer will simply move forward and arrange the element to be filled at this K position. Okay. And here we are also going to take one counter, and this counter will make sure that each and every element will occur in the final result at most 2 times. So this counter will initially be 0. After that, let's try to solve this problem and try to make conclusion out of it. So first we will see that we will try to compare these both elements I and J. So let's try to compare them. So it is saying that nums of I is equal to nums of j. So nums of I equal to nums of j. So that means we have one more element, and as this place is already filled, so this I is basically representing the place that is already filled, because this is the position which we always have to take, because if we will see this, this is unique in itself, as this is the first element, there is no more element uh, preceding to that, so it is the element which is already the unique element. So this is basically representing the element that is already filled. This K is basically representing the position that is needed to be filled when we will traverse further. And this J will basically help to arrange the element to be filled at this place K. Okay, so first conclusion, let's try to make conclusion out of it. So it is saying that this nums of I equal to nums of J. Okay, and this counter is initially 0, and this J is basically equal to K. So the first conclusion that we have made is that nums of I equal to nums of j, and this counter is less than 1. Why less than 1? Because we can take only two elements, and as this counter is set to 0, it is basically saying that we have already taken one element, we have to take one more element. And when this counter will change to 1, that is simply representing that now we do not have to take any extra element of the any extra same element, because it has already crosses the limit, because our question is saying that we can only take at most each and every element for at most two times, so it is exhausting the limit. So after that we do not have to take the same element again. So this is the counter which is representing it. Yes, it is initially 0, which is representing that one element we have already taken. And as this counter will go more than 1, then it is simply mean that we do not have to take this element and include it into our result. So it is saying that counter is lesser than 1, and this j is equal to k. So in this case, what we have to do is, basically we have to include this element, as if we will include this element, then this 0 will occur for two times, which is okay. So we have to include this. So what we will do, uh, we will simply increase this j pointer. So we will simply increase this j pointer. Also we have to increase this k pointer, as this position is already filled, so uh, it will simply go here at this place, and it will represent the next position to be filled. So this k will also move forward, and we also increase the counter, as the frequency of 0 we got is now 2, as these two positions are already filled. So we will also increase the counter. So this is the first conclusion that we have made. Now moving forward, this j will come here, and this k will also come here. Now again we will compare between this I and j, that if nums of I equal to nums of j and condition is false, nums of I is not equal to nums of j. In that case, what we have to do is, it is saying that another conclusion is, if nums of I is not equal to nums of j, so nums of I is not equal to nums of j, and it is saying that this j is equal to k. So that simply means that we have found the next element that is to be included into the result, and which is not equal to this I position. So we have uh, this nums of I is not equal to nums of j, that simply represents that we have found some newer element, and this j equal to k is simply representing that we have found the element for the first time. So what we will do, as this element we have to include in our result, so this is already filled position. So as this I is representing the position that is already filled, so we have to move this I pointer at this place of k. So what we will do here, we will do one thing, I equal to k. After that we have to move these both pointers j and k, So we are simply moving these pointers ahead, G++ and K++. And as we are getting this element for the first time, so we will simply make this counter as 0. So simply make this counter as 0. After that, what you have to do is increase this J. Also increase this K pointer and put this J pointer and at place of K. After that, again, you have to check the condition is nums of I equal to nums of j. Yes, nums of I equal to nums of j. Is counter lesser than 1? Yes, counter is lesser than 1. Initially, this counter is 0. And j is equal to k. Yes, j is equal to k. So what we have to do is we have to include this into our result. So we will do j++, k++, and counter plus plus. Means that is simply saying that we have got this element for the second time. So this place is filled, and we will simply increase all the counters. This counter will change to 1. After that, this j will come here and this k will come here. After that, we will again check this condition. Is nums of I equal to nums of j? Yes, nums of I is equal to nums of j. Is counter less than 1? No. Now this time this counter is equal to 1. So this condition is violated. So here we can make another conclusion that if nums of I equal to nums of j and counter is greater than or equal to 1, then what we have to do in this condition? In this condition, basically, we have to increase the value of the counter as we have get this element again. So increase the value of this counter, and in at this time you just have to increase the pointer j. Why you just have to increase the pointer j? Because this is the position which is needed to be filled. Now this position can't be filled with this one because already we have taken this one for 2 times. Now we have to arrange some another element, and as this j is responsible for arranging a newer element, so this j will move forward and try to arrange the element for this position k, because we can't take this one. So simply we will move this j forward. So counter will move forward and this j will also move forward. So this is the third conclusion that we have made. Now simply try to increase this j. J will come here. Again we will check if nums of I equal to nums of j. Yes, nums of I is equal to nums of j. So and this nums of I equal to nums of j, and this counter is greater than equal to 1 because this counter is 2. So what we have to do, we just have to increase this counter and this j pointer. So we will simply increase the counter and make it 3. And after that we will increase this j pointer and j will come here. Now again we will compare nums of I equal to nums of j. No, nums of I is not equal to nums of j, and nums of I is not equal to nums of j. Okay, this is the condition, and j is equal to k. No, in that case j is not equal to k. So this is the fourth conclusion that we have made, that if nums of I is not equal to nums of j and j is also not equal to k, in that condition what we have to do, basically this j is responsible for arranging the element. So this j has already arranged the element, as this is not one, it is some another element we have got for the first time. So basically this j is not equal to k. So what we will do, we will simply put this take this element and put at place of k, which is the next position to be filled. So we will take this element and put it here. So what we will do, we will make nums of k equal to nums of j. So this is the first thing we will do. After that, what we have to do now, as this position is already filled, we have put this 2 here at this position, and at this position is already filled, and the already filled position is represented by this I pointer. So what we will do, we will simply take this I pointer and keep it here. So we will simply take the psi pointer and keep it here. And after that, we will simply increase this k pointer and increase this j pointer. And we also have to make this counter as 0, as we have got some newer element. So now we have to count the frequency of that newer element. So we will again make this counter as 0. So what we will do, we will make this I equal to k. After that, we will increase this k pointer, we will increase this j pointer, and we will simply make this counter as 0. So this is the fourth conclusion that we have made. After that, again we will check this condition. Is nums of I equal to nums of j? No, nums of I is not equal to nums of j, so we will simply come here. And j is equal to k? No, j is also not equal to k. So what we have to do in that case? In that case, we simply have arranged some newer element to be filled at this k position. So we will simply take this element and put it in place of k. So simply do this. Take this element and put it in place of k. So 3 will come here. After that, make this I equal to k. So I will come here. So take this I and put it here because it is representing the position that is filled. Now this k will go one pointer forward because we have this k is representing the next position. So we will simply increase the k again. After that, we will simply increase this j pointer. And as we have got a newer element, so this counter will be equal to 0. So it is already 0. You simply override this. After that, again this condition is checked. If nums of I equal to nums of j, yes, nums of I is equal to nums of j. This position is already filled. Nums of I is equal to nums of j. Okay, and counter is less than 1. Yes, this counter is less than 1. And j is equal to k. No, j is not equal to k in that place. J is not equal to k. So this is the last conclusion that we have made, that if nums of I equal to nums of j and counter is lesser than 1, but this j is not equal to k. So what we will do here, here we will do simply, we will take this 3 and put it in place of this k. So we will take this and put it in place of this k. So 3 will be placed here. After that, we have to make this, we have to increase this pointer k. So k will come here at this place. K will come here at this place. It is representing the next position to be filled. And j will come here at this place. And we will simply increase the counter. So counter will get increased. So what we will do? We will do nums of k equal to nums of j. After that, we will increase the k pointer, we will increase the j pointer, and we will increase the counter. Okay. After that, as we can see, this j is already exhausted as it is now out of this array. So now it is representing the place which is not inside this array. So j is already exhausted. So we will move forward till the position this um, j is less than nums dot length. So till this position, we have to move forward. And when once this j is exhausted, then we will come out of the loop and return this value k. As now this value k, if we will see as per the indexing, then this is the indexing and 8. Now this k is representing the seventh index, and the number of elements that are after the final result, the number of elements inside this array will be 1, 2, 3, 4, 5, 6, and 7. So basically this k is representing the actual result. So finally we will return this k out of this result. So if we will try to analyze the time complexity and space complexity of this solution, then this time complexity, as we are traversing this whole nums array, so we are traversing it only for one time, as this j always keep move forwarding. So the time complexity is equal to the length of this nums. So let's say it is n. So time complexity is order of n. That is linear time complexity, which is good. And this space complexity, as we are not taking some extra space, as this space is only for visualization that how these elements are placed inside this nums array. So it is not some extra space. So the space complexity is O of 1. That is constant space complexity, as we are not taking any extra space. So now let's go and try to implement this solution. So first take 3 pointers, I equal to j, I equal to 0, j equal to 1, and k is also equal to 1. And take one counter, which make which basically makes sure that each element will occur in the final solution at most 2 times. Now we have to move till this j is lesser than nums dot length. And we also have to, after that, let's try to populate each and every condition. if of nums of I equal to nums of j, and this counter that we have taken is lesser than 1, uh, and the third condition is this j is equal to k. So what we have to do in that case? In that case, we simply have to increase these three counters j, k, and control counter. So what we will do? We will simply do j plus plus. After we will do k plus plus and counter plus plus. The next condition we have is if, let's say, nums of I equal to nums of j and counter is less than 1, but this j is not equal to k. In this, what we have to do? We will simply fill this position k, nums of k equal to nums of j. After that, we have to increase the counter, and we have to make this I equal to k. Let's see it here. Okay, we have to increase this k, j, and control counter. Third condition is nums of I equal to nums of j, and this counter is basically greater than equal to 1. In that case, we simply have to increase the value of counter and increase the value of j. J will move forward and try to arrange some element for to be placed at this place k. The next condition is I not equal to nums of j and j equal to k. In that case, what we have to do? We have to make this I equal to k and increase this j pointer and k pointer and make this counter as 0. We will make I equal to k, increase k pointer and j pointer and make this counter as 0. As if nums of I is not equal to nums of j, and if j is also not equal to k, in that case, basically we have to make this nums of k equal to nums of j. After that, we have to make this I equal to k, increase both the pointers and make counter as 0. Nums of k equal to nums of j, counter equal to 0. So this is the final solution. And as we have to handle the base case also, so let's handle these base cases. Let's say we only have one or two element into our array. So if we have one or two element into the array, then we will simply increase the number of element in the array. As if there is one element, then this will always be unique. And as if there are two elements, then either these two elements are different from each other. In that case also the result will be two. And if these elements are even similar, then in that case also we have the result equal to nums dot length, as two elements are allowed to be taken. So what we will do, if nums dot length equal to 1 or nums dot length equal to 2, in that case we will simply return nums dot length. So let's try to run this. Okay, we have to return this k finally from here. So simply return this k. Okay, both the test cases are passed. Let's try to submit this. And it is submitted successfully and it is accepted. So that's all for today. Thank you.